Welcome to Vikrant. Myself, Dr. P. Chitralingappa. Today we are going to discuss about the data link layer from the part of the computer networks. So this is complete syllabus of the data link layer. Data link layer uses services of the physical layer and send and receive bits over the communication channel. So it has some functions. The first one is so it will provide services to the upper layer as well as the lower layer, dealing with the transmission errors and regulating the flow control. So these are the three important services or functions at the data link layer. The data link layer mainly deals with the frames. Frame is combination of the header and trailer followed by the payload. Payload is nothing but the original data. Data link layer is divided into two sub layers. One is the logical link, logical link control, and mid-access control. Logical link control mainly deals with the error control, data flow, and framing, and max sublayer mainly deals with the dynamic channel allocation, physical addressing. So these are the two important sublayers, and we are discussing these sublayers detailedly. And media access control layer mainly deals with the congestion control, try to reduce the congestion. Why? Because so we are sending data at the same time many devices into the channel is unable to regulate the flow. So for that purpose we have, there are so many congestion control approaches are there. We can use those approaches, try to reduce the congestion. Okay, there are congestion controls are divided into three categories: random access protocols and controlled access protocols, channelization protocols. Data link layer has some design issues. One is the framing and error detection and error correction, flow control, media access control, addressing. These are the some of the important design issues or functions of the data link layer in this case. So flow control is nothing but regulate the incoming and outgoing flow. Sender wants to sending the data, keep on. Receiver is also receiving the data, keep on. So what happened in this case? Suppose sender sending the data with more speed, receiver is unable to receive in that speed. So at that time there is a possibility some data may be lost. Try to regulate that flow, incoming as well as the so outgoing. For that purpose there are two approaches are there: the feedback based flow control, rate based flow control. In the feedback based flow control, based on receiver input, sender has to send the data. In the rate based flow control, in the system itself try to fix some rate. With that data rate only we can transmit the data. And error detection and error correction, in this case error detection involves adding some random data to the original data, and we can verify that additional information at the receiver end. That is called as the error detection technique. And error correction technique, what we are doing, we are correcting the missing data into the error detection error correction techniques. Error correcting codes are the Hamming code and binary convolution codes, Reed-Solomon codes, low density parity check. So we are focusing only in this case Hamming codes only. There are two main types of error correcting codes are there: block codes and convolution codes. So block codes operate on the fixed size block of data, and convolution codes we can use for the continuous stream of data. And Hamming code, in the Hamming code, what we are doing, we are adding some additional information to the original data, and we can do some processing, and we can send that information to the sender and to the receiver end. Receiver is going to be verifying whatever the data we're adding with the help of some thing. So these are the steps we're doing at the Hamming codes. The first thing is calculate the number of redundant bits. So how many number of duplicate data we are going to add to the original data. So try to calculate by using this formula. 2 to the power of r greater than or equals to m plus r plus 1. M is the original data. So how many bits of data we are going to random amount of bits into the thing. Next one is the positioning the redundant bits, and whatever the bits we are adding into the original data, but at which place we're adding the those bits. So try to calculate the position also. Next one is the calculating the value of the each redundant bit. Whatever the bit we're adding, try to calculate that bit by using the two approaches. One is the even parity and odd parity. So even parity is nothing but total number of bits in the message is made even. Odd parity is total number of bits in the message is made odd. And this is one example is there, sample example. So I have taken one message, the given one message m, this is the message, and I am using the even parity approach. In this case, now try to calculate the r value based on this formula. Try to calculate the r value. So I got r value is 4, which means 4 bits I am going to add. So p1, p2, p4 and p8, these are the 4 bits, 4 redundancy bits, random amount of bits we're going to add into the original message. So now I'm adding, the first one is the calculate the number of bits. Second step is the try to calculate the exact place where we're going to add those bits. So I'm adding these bits here. So finally this is my code word, this is my code word. Now try to calculate the what is the p1 value, p2 value, p4 value and p8 value. So by applying some approach, we can calculate those things. Now finally, so at the receiver end is also again we're going to verify the things, calculate the number of redundant bits and positioning the redundant bits and parity checking and error detection and error correction. So if we get the same at the receiver end, I'm talking about at the receiver end, decimal equivalent of the parity bits binary value is calculated. If it is 0, there is no error. Otherwise, try to correct it at the receiver end. And error detecting codes. In this error detecting codes, we have three approaches. One is the parity checksum and CRC, cyclic redundancy checksum. So in the parity, what we are doing, so we are adding the either one extra bit to the original mess and try to calculate the even parity, odd parity. This is very simple. The checksum also what we are doing, the checksum is nothing but check plus sum. So what we are doing, so this is at the sender end, whatever the message given to you, you can sum those message. So all the information you can sum, you will get the some carry. Again, you can add that carry to the your original message. Then you will get some information. Then try to apply the complement. Once complement, then you will get this message. This is called as a checksum. Now try to add this checksum to the original information, and you can pass at the receiver end. So receiver will receive the original data along with checksum. This is the original data along with checksum. So again you can apply the same process. Finally you will get the result is all the ones, there is no issue. And CRC, cyclic redundancy check, this is also very important for examination point of view. In this case what you are doing, just go through the problem, directly go to the problem in this case. Yeah, so they are given one frame, this is the frame, this is the generator they are given. So try to convert this generator into binary form like this, and you can divide the given frame by using the generator, and you can apply the XR at the each and every time. Finally you will get something. Before that, what you have to do, try to add additional number of bits into this your case. So here number of bits are 5, you can add 4 bits and you can apply the division. Finally you will get some reminder and you can add this reminder to the your original text. So this is the original text. So after adding the number of zeros, finally you will get some information. This is called as a code word. You can pass this code word to the sender. So like that you can calculate the things. And the elementary data link protocol. So these are the some of the protocols we are using in this case. These are divided into two categories: noiseless channels and noisy channels. Under noiseless channel, we are using the simplest protocol, stop and wait protocol. Under noisy channels, stop and wait ARQ, go back and ARQ, select to repeat ARQ. Simplest protocol in this case, sender is sending the frame only, but we are not getting any acknowledgement. Sender sending the frame, receiver receiving the frame. That is called as the simplest protocol. Only one direction. We are sending the data, that's all. And coming to the stop and wait protocol, what we are doing, sender sending one frame and receiver is sending one acknowledgement to the sender. So here acknowledgement plays an important role in this case. This is called as the stop and wait protocol in this case. Some of the drawbacks are there in the stop and wait protocol. Sender will not send the next frame. What happened? So in this case, there are propagation delay and transmission delay is there. Try to overcome this propagation delay and transmission delay with the help of the stop and wait ARQ. So in the stop and wait ARQ, what you are doing, sender does not receive acknowledgement message within the certain time period. It assumes that the frame was not successfully received. So again what you have to do, try to retransmit that frame only. So that is the drawback. In case of stop and wait protocol, we are sending the one frame, but we are receiving, but we are not getting any acknowledgement so far. Then what we have to do, sender is waiting, keep on waiting to get the acknowledgement. So in this case, that is a drawback. To overcome that drawback, stop and wait ARQ, what we are doing, we are sending the frame, again retransmit the frame within a certain amount of time. Sliding window protocols are stop and wait protocol and go back and select a repeat ARQ. So these are the some of the important protocols in this case we are using. So there are two windows are there. One is the sending window and the second one is the receiving window. So try to send some window data to the frames to the at the next level. Let us assume. So this is one small example. So here there is a sender window is there and receiver window is there. Now what we are doing, we are sending the frames one by one. For example, the sender window capacity is 4, receiver window capacity is 4. Now what happened? Frame 0 is frame 0, frame 1 sent. Now what happened? Whenever any frame is going to be sending, immediately the window is going to be moving to the next frame. And the receiver is also, receiver and also whenever we are receiving any frame, window is going to be sliding to the next frame. So these are the two important protocols: go back and ARQ, select repeat ARQ. The go back and ARQ, what we are doing, the sender can send the multiple frames before receiving the acknowledgement for the first frame. So don't want to wait for the first frame. So whatever the window size is there, until that window size, try to send all the frames without any acknowledgement. But after whenever the window is full, and wait for the acknowledgement. If you get any one acknowledgement from the receiver end, then you have to transmit the next frame. That is the thing. But for example, somewhere there is a one frame is going to be unable to receive the acknowledgement. In that particular point, the go back and ARQ, what we are doing, we can retransmit the all the frames. Entire window we are going to retransmit. That is a drawback in the go back and ARQ. In case of selective repeat ARQ, which frame is going to be unable to receive the acknowledgement, only the respective frame only retransmit again. That is the drawback overcome by the selective repeat ARQ request. Selective repeat protocol is also known as the selective repeat automatic request data link layer protocol uses the sliding window technique. The sender sends the several frames specified by a window size in the selective repeat without waiting for individual acknowledgement from the receiver as in the go back and ARQ. In this case, what we are doing, so this is the original scenario. Sender and receiver is there. We are going to send that 10 frames. Window size is 4. Window size is 4. So now what I am doing, so without any acknowledgement, I am sending the first frame, second frame, third frame, fourth frame. Why? Because the frame size, sender window size is 4. So without expecting any acknowledgement, try to send the 4 frames. Okay. And I will get one acknowledgement from the frame 0. Now what I want to do, I want to move the window slide into the next frame. Why? Because the window frame size should be 4. Now sending window size is 1, 2, 3, 4. So already I sent 1, 2, 3. Remaining is 4. Now I am going to send the fourth frame here. So like that, whenever you are getting an acknowledgement from the receiver, then you can move slide to the next frame. Why? Because the sliding window size is always 4. And in case again, so again I am getting one more acknowledgement from the receiver, which is the second frame acknowledgement. Now the frame size is, again I want to move my frame into the next 4. Again 2, 3, 4, 5. So I want to send again fifth. So like that you can apply this mechanism. And in case anywhere something is wrong, you can retransmit the all the frames. You can retransmit the all the frames, but that is not there in the selective repeat ARQ. The media access control layer, multi-access channel is the combination of the channel that allows multiple nodes access the simultaneously, enabling data exchange between the multiple devices on the same channel. There are two broad categories are there. One is the broadcasting point to point, and we will discuss this one. So these are the some of the protocols and random access protocols: Aloha, CSMA, CSMA CD, CSMA CA, and controlled access protocol, reservation, polling, token passing, channelization protocols, frequency division multiple access, time division multiple access, code division multiple access. Random access protocols are the random access methods. There is no station that is superior to other station, and none is assigned control over the others. So in this case, what you are doing, randomly any station has to transmit the data if data is available. So in case if there are two or more stations that try to send the data, there occurs a conflict in the access, that is called as the collision. Random access protocols are divided into Aloha, CSMA, CSMA CD, carrier sense multiple access, with collision detection and collision avoidance. So this is the difference between the pure Aloha and slotted Aloha. Carrier sense multiple access. Carrier sense multiple access ensures fewer collisions as the station is required to first sense the medium before transmitting the data. If it is ideal, then it sends data. Otherwise, it till waits till the channel becomes ideal. So there are two categories of the CSMA protocols are there. One persistent, non-persistent, and P persistent protocols. CSMA CD is If the two stations sense the channel to ideal and begin transmitting simultaneously, their signals will still collide. Quickly detect the collision and abruptly stop transmitting. Saves the time and bandwidth. So for this protocol is CSMA CD protocol with collision detection. So the stations hardware must listen to the channel while it is transmitting. If the signal it backs reads back in the different from the signal it is putting out, so it knows that collision is occurring. CSMA CA carrier sense multiple access avoidance protocol. So it designed to avoid collisions between the packets by sensing the medium before transmitting. So it must listen to the channel to check whether it is busy. If the channel is ideally, station can start transmitting. If the channel is busy, station must wait for random amount of time before attempting to transmit again. So the CSMA CA uses a mechanism called as the RTS and CTS frames. Request to send, clear to send. By using these two things, we can get the information. So this is one example. So in this case, what happened? B wants to send the data to the C. B wants to send data to the C. So in this case, this is the station B. Station C wants to communicate with each other. So station B wants to send one RTS signal request to send. If whenever it is sending signal, immediately this the remaining is going to be blocked. The remaining is going to be blocked. This process we can call it as a NAV, network allocation vector, is a virtual timer maintained by the each and every station. So until and unless the further instructions, the remaining communication with the node B is going to be stopped. And whenever node C is going to be send confirmation as the CTS, clear to send. Again, this area is going to be blocked until the further clearance. This is called as the NAV, which is virtual timer. Now, after getting the clear signal, data is going to be transmitting and we're getting the acknowledgement. So this is the complete process. Whenever this process is completed, then this remaining place is going to be released. Like that, we can send the data from the RTS and by using the CTS thing. So this is called as the MECA protocol or RTS CTS handshake protocol. And coming to the Ethernet, Ethernet in computer networks is a wired technology used to connect the computers in a local area network and MAN and WAN. And majorly we are using the IEEE 802.3 standard, which defines the physical layer and as well as the MAC sublayer. Ethernet is a family of the networking technologies and protocols that are used to transmit data between the devices over the wired or wireless communication. It is divided into two categories, classic Ethernet and switched Ethernet. So classic Ethernet, the data transmission should be up to 10 Mbps speed only. So switched Ethernet is again divided into T categories. One is the fast Ethernet, the data transmission should be up to 100 Mbps, gigabit Ethernet 1 Gbps, and 10 gigabit Ethernet 10 Gbps data should be we can transmit by using this medium. And frame formats are preamble is there, destination address and source address, type and length, data, padding, CRC. So this is the Ethernet frame. In this Ethernet frame, what we are doing, the destination address is there and source address is there, length is there. This is the data padding. So minimum payload length is 46 bytes we can transmit. The maximum payload length is 1500 bytes of data we can transmit the things. And the minimum frame length is 512 bytes or the maximum frame length is 512. So this is payload, which means the original data whatever we're transmitting, that is the minimum and maximum. This is the frame length. The frame length should be 512 or 64 bytes. This is the 1518 bytes, and we are using the CRC. So this portion we can call it as a header, and this portion we can call it as a trailer. This portion we can call it as the payload. This is the three portions are there in the frame. Each and every frame containing the header portion and trailer portion and payload portion. So